Hi, this is the quiz review. We're going to go through each of these problems. Make sure you show all the work just like I do on here and practice these a few times. So let's get started. On 1A, we have the square root of negative 25. So you might already know the answer, but it's good to know why and how it works. So we can break this up into negative 25 times negative 1. 25 times negative 1. And the square root of 25 is not 5. Don't forget that. Square root of 25, what number times itself equals 25? Is positive and negative 5. Right? And of course, the square root of negative 1 is just I. So we got two answers here. Okay, so this might look like an easy problem. Don't forget there's two answers. For B, right, this is just going to be a 2 times 4 and I times I. So we have 8I squared. And don't forget that I squared equals negative 1. So this is really equal to negative 8 when you simplify it. So every I squared just replaced with a negative. All right, we have C. All right, so we're adding here, right? So we're just going to combine the real parts. We got the 7 and the negative 3. That would make 4. Right? And we have the negative 5i and positive I, so that's negative 4i. So nothing more than that. Okay, let's go down to D. Now let's do a little multiplying, distributive property, just like always. 3 times 2 is 6, and 3 times negative 4 is negative 12i. All right, now we can do a little multiplying. And if you want to make a box, you can do that. Just remember there's 4 multiplications regardless. So we have 2 times 1 is 2. 2 times negative 2i is negative 4i. And then we have I times 1, another I. And I times negative 2i. So negative 2i squared. Right. Once again, any I squared you can replace with a negative. So drop the I squared, and negative of a negative is going to be positive. So now we have 2 plus 2, which is 4. And we have negative 4i plus I, negative 3i. All right, and lastly, we have a division problem, so we have to do a little conjugating. So that means you take the bottom term, multiply by the conjugate, which is just the opposite sign of whatever here. So we have 3 minus I, and of course, let's do the top and bottom. So we got to multiply all the top out, all the bottom out, and simplify where possible. So we have 2 times 3, 6, 2 times negative I, negative 2i, negative 2i times 3, that's negative 6i, and negative 2i times negative I is going to be positive 2i squared. All right, simplify the bottom. We have 3 times 3, 9. And since these are conjugates, they have a special property. The middle terms will cancel out because we'll get positive 3i. When we do it, we get this one, we'll get negative 3i, but then we'll get positive 3i. Right? And that's why we choose to multiply by the conjugate, is for these i's to cancel out every time. So we're not going to have any middle terms. We're just going to have the first times first, and then the last times last, which is negative I squared. All right. Now, of course, both of these have an I squared, so this I squared is going to make this negative. All right, so that's now negative 2. And this I squared is going to make this plus 1. So we have 6 minus 2, which is 4. And then negative 2i, negative 6i is negative 8i. It's on the top. And on the bottom we have 9 plus 1, which is 10. And we could probably simplify this a little bit more. Let's do a little GCF here and factor out, let's say, a 2. So we have a factor of 2, taking that out. And of course, the bottom can also be written as 10 is 2 times 5. So therefore, these 2's cancel out. And our final answer is just 2 minus 4i over 5. All right, now let's go to the trig form. All right, so here's where we need to know what we're trying to do. Let's start with that. Trig form means we're going to write it in this format. The radius is cosine theta plus I sine theta. All right, so we know what that is. That means from this information, we need to come up with what the radius is and what theta is, right? And just put it right in this form. Okay, so first things first, let's do the radius. It's good to know also what quadrant we're working in here, right? So if you had a graph and you're going to go negative and plot this, it'd be negative 7 over 2, or 7 root 2, that's to the left. And then minus 7i root 2 would be down. So that puts us in the third quadrant. All right, so we're working third quadrant somewhere down here, right? Let's say we don't know where it is. So we need to find this length right here, radius, right? And we know these values, right? So let's make it a little thinner. We know that this is negative 7 root 2, and this is negative 7 root 2. So we can do Pythagorean theorem to figure this out, right? Or if you know the shortcut for special right triangles, you could do that as well. But we're just going to write it out like you don't know the shortcut. That equals r squared. All right, so this is going to be 7 root 2 times 7 root 2. So 7 times 7 is going to be the 49. And root 2 times root 2 is going to be 2. And we'll get the same for both of these. So this is 98, 98, which means we have 196 when you add those up. Square root of 196 is 13. No, sorry, 14. Yeah, 14. Square root both sides. So our radius, our first part of our answer, we have now. Right? We know that it's going to be 14 times cosine. Don't know the theta yet. I sine. Don't know the theta. So I just have to find out what theta is now. So theta, all right, is this angle right here. And we have a rise, right? And we have a run. So you might recall the way to find an angle with rise and run is the tangent, right? Or you could look at it this way as the tangent of the theta, if I have the rise and run, right? That means the actual theta will be the arctangent of this. Right? And you can see you get the same exact thing on top and bottom. So this is saying basically what angle has a tangent of 1, positive 1. Right? What angle has a tangent or a slope of 1? And it's in the third quadrant, right? So you should be able to figure out that that's going to be 225 degrees. Right? That's the 45-degree angle in the third quadrant. You can think of it as 180 plus 45. Right? That'll work. You could also write it as radians if you prefer. So you could write 5 pi over 4 if you prefer that. Either way is acceptable. Okay. So just put one of those two in both of these. 225. I'll pick that. All right, so same story as before. You got to know your unit circle in order to do these. Okay. let's look at 15i. So again, we have to find out two things, right? The radius and the angle. And when it's just a single term, it usually means it's an easier problem compared to this, right? That means, since there's only one term, like it only this has the real and the imaginary, this only has the imaginary. So this is the same as 0 plus 15i, if that helps. Because if you plot it, if you graph it and see what it looks like, well, 0, that's the left and right, right? This is the real, AB, so we're not going left or right. 15, right, that means we're going up here 15. So the distance, you know, if you're trying to find the radius, well, how far is it from here to here? That's your radius, right? It's 15, right? So no Pythagorean theorem needed, because you really only need this if you're not at a horizontal or non-vertical, right? If you're at an angle, like this, you know, is an actual angle, but if you're on the axis, there's no need for it because there's no run. You could do it. You could do 0 squared plus 15 squared and then take the square root, but of course that would just be 15. So we already have the first part of our answer. It's going to be 15 for the radius. And we got cosine plus I sine. All right? And ask yourself, well, what is this angle? Right here, from here to here. What is that angle? Hopefully we can identify that being 90 degrees or pi over 2. This time I'll put pi over 2. You can put 90 if you wanted. Okay? So you can see how fast these problems are. If they just have only a real part or an only imaginary part, they lie somewhere on the axis, which makes it a really fast solution. All right, let's go down to number 3, and we're going to simplify this. We're going to go the other way, right? So we went from the AIB form to triangular form or trigonometrical form. Now we're going to go in reverse. Start off with that and work our way backwards to have A plus BI. So this is strictly a, I'd say a unit circle problem, right? So we have to know the unit circle well enough. Sometimes, like we have this negative here. If you don't like the negative 300, right, just convert it to a positive. That's the same thing as cosine of 60. Right? As long as we know what the cosine and sine of 60 are, the unit circle, 1/2 plus, let's see, I root 3 over 2. All right? And then just multiply 2 root 3 by each of those. So we have 2 root 3 over 2 plus 2 root 3 times root 3 over 2. And of course, each of these simplify. 2 over 2 cancels. We have just root 3 for the real part. And then we'll have these 2's cancel. And I have root 3 times root 3, which is just 3 for the imaginary part. Should put that I on there as well. There we go. Okay. All right, let's go to B. Same thing, just in radians, so we have to know our unit circle. It's over 4, so we know those are going to be some root 2's over 2's. Now ask yourself which one's positive, which one's negative for 3 over 4, right? What quadrant is this in? And then you'll remember that, okay, this is quadrant 2, so that means cosine is actually negative. So, small but important detail. So we have what? I'll write it all the way out. So we have negative 12 times root 2 divided by 2 plus 12i root 2 over 2. And on both of them, we'll have those canceling out and getting a 6. The final answer will be 6 root 2 for the real, and, negative 6 root 2. And we'll have 6i root 2 for the imaginary. let's evaluate these. So the rule was to when you're doing multiplication, we're just going to multiply the two radii and add the angles. So we have cosine of pi over 4 plus 3 pi over 4. Of course, the same for the sine, pi over 4 plus 3 pi over 4. All right, so we have 20. And pi over 4 plus 3 pi over 4 would be 4 pi over 4. Like 1 plus 3 is 4. 4 divided by 4 is just going to be pi. And if you look at this from degrees point of view, this is 45 degrees plus 135. So 45 plus 135 is 180. So it doesn't matter which units you use, same result. So now we just have to do cosine of pi and sine of pi. So cosine of pi is -1. And then we have sine of pi, which is 0 I. So we'll end up with just -20. And if you want to put the 0 I, you can, but not required. Asterisk, that part's not required. Right there. You could just put the -20. All right, next let's do a division problem. So we're going to divide the radii this time and subtract the angles. All right, so we'll have 4 cosine of -120 plus I sine of -120. Okay. And you can rewrite this as 240 degrees if you like, if that makes you feel better, but you don't have to, as long as we know where that is and we know the values. This is third quadrant, right? So both the sine and cosine are going to be negative. And we'll have -1/2 minus √3 over 2I. And distribute this, so half of 4 is 2 with a negative, okay, -2. And then we have if we had a 4 here, 2 will go into 4 2 times, so we'll have a minus 2 radical 3 with an I. And this part right here, some people like putting the I at the end. If you wanted to put the I right here as well, that's just as acceptable. It just depends on your preference. Personally, I like it this way. All right, let's move on to the back. Oh no, we got a few more. Got excited. Oh, a few more divisions, just in. Oh, I see. Okay, so these are in radians. So let's do same thing as we did before. 6 divided by 2/3. This is a division problem. We're going to divide these radii and subtract the angles. So pi over 2 minus pi over 2. 2 pi minus pi over 2. So I sine. Okay. And let's see here. 6 divided by 2/3 will give us 9. We need to do that with the sides. 6 times 3 over 2. 18 divided by 2 gives us 9. We have 9. And 2 pi minus pi over 2 is simply just -pi over 2, right? Or 3 pi over 4, or 3 pi over 2. Yeah, so you can do that either way you like. We got cosine of -pi over 2. And that would be unit circle time, 0, and -1I. So we have, of course, 0. We multiply here, and we have -9I. as our final answer. Again, if you want to put the 0 minus negative 9i, you can, but this is fine, just as is. Alright, back to multiplication, so I'm going to multiply 10 times 2/5, 2/5 of 10, and add some angles. Cosine 300 plus a negative 60, plus I sine of the same. Alright, so 2/5 of 10 would be 4. And 300 minus 60 will be 240. Back to 240. We used that earlier. And still has the same values of negative 1/2 and negative 3/2i. Half of 4, negative 2. There we go. Okay. Now we can head over to the back. Alright, so we're going to use the next property we learned that handles exponents. So we just finished multiplying and dividing. Next would be exponents. So that said, the rule there was you do r to the n power, right? And it'd be cosine n times theta, right, plus I sine n times theta. Right, so I need to rewrite this in our trigonometric form and then convert it this way. Okay, so back to the same thing. To write in this form, I need two things. I need my radius and I need my thetas, right? So same thing as we did before. Let's find the radius and let's find the theta. So we have, let's see here, what quadrant is in? Always good to think about that. So if I plotted this, -1 plus I would be in the second quadrant, right? So I'm working in the second quadrant where I have -1 as the run and +1 as the rise. Right? Now, if you already know, like you might know this, that the radius from that makes it √2. That's fine. If not, you could go through and do -1 squared plus 1 squared equals r squared, and show all the work just to find out that, yeah, r equals √2. But after doing enough of these, you start seeing patterns, and it becomes less necessary to maybe show some of those calculations, and that's okay. Right? In the thetas, same thing. You might look at this and say, well, I know since these are both 1, that makes this a 45-degree angle, so you might be able to look at that and figure out pretty quickly that that's 135 or 3 pi over 4. But if not, you could always do the arctangent of rise is 1, run is -1. So this is the arctangent or slope of -1. What angle has a slope of -1 in the second quadrant, right? And that would be, once again, 135 or 3 pi over 4. Okay. So there's our theta, and we have an r, so we can write it in the right format. So we have 2 times cosine of 135 plus I sine of 135, right? And that's what this part right here is equal to. All right, we just wrote it in trigonometric form. So now it's raised to the 5th power, and we can just use this property and do √2. I'll leave a little space here. Cosine 135 plus I sine 135 Right, so with this, I'll do the fifth power, right, and then multiply it by the angles. So 5 times 135, and so on. All right, so I have to multiply this out. It needs to be an exact answer. So if you put in some calculators, you get a decimal. Some give you the regular, the full exact answer. But one way or another, we have to know that this equals 4 times root 2. All right, if you need to, you can just multiply it out to the fifth power, right? So that's what this means. Root 2 times root 2 is 2, and then another root 2 times root 2 is 2, and then that's by itself. So we have 2 times root 2, which of course is the 4 root 2. And then we can multiply this. We have cosine of 5 times 135. Let's see here. It's 5 times 135, which is 675. So we have to figure out, well, where is 675? Right, and you can do that by subtracting 360 from there. So if I subtract 360, that takes us down to 315. That puts us in the fourth quadrant. So cosine of that would be, of course, root 2 over 2. And we're in the fourth quadrant now, so cosine will be positive, sine will be negative. So we have 4 root 2 times root 2 over 2 minus root 2 over 2i. And then finally just multiply this all the way through. So we have, I'll write it out, 4 root 2 times the root 2 over 2 minus the same with an I. And then simplify each one of these. So we'll have, looks like, let's see, root 2 and root 2 equal 2. So these will cancel out. So we'll have 4 minus 4i. All right, let's continue on. By the way, if you have extra time you want to check, you could actually multiply this out 5 times. Negative 1 plus I times negative 1 plus I plus negative 1 plus I. These are pretty small numbers, so even though you have to do it 5 times, it kind of happens really fast. But if you did that, you would get the same exact answer. It would just take longer. That's why we like this format as opposed to sticking with like rectangular coordinates. All right, let's go to here. Oh, missed it. All right, so same thing, just a little more practice. Numbers are a little different, right? So we can do the same thing. Let's find the R. All right, let's know what quadrant we're in. So positive cosine, negative sine. That means we're in the fourth quadrant. So always good to visualize where we actually are. So we're going to be at positive 3, down 3 root 3. And so we're going to be positive 3, down negative 3 root 3. Remember, don't include the I here. And then we just have to find what this radius is. So R squared will equal 3 squared plus negative 3 root 3 squared. So we have 9 plus negative 3 times negative 3 is 9, and then root 3 times root 3 is 3. So we have 9 plus 9 times 3, which is 27. That makes this equal to 36. So our radius is a nice number of just 6. All right, and then that's part 1. So I know my trig form will be 6. Right, and then I just need the angle now. Alright, so let's do the angle. Same thing. We have theta will be arctangent. Just going to use at this angle, so opposite, or the rise is negative 3 root 3. The run is 3. Right, and you might recognize this, right? The 3's cancel out, so it's really just a slope of negative root 3. And if you remember the unit circle, that's going to be equal to 300 degrees. Or if you prefer, you can use negative 60 degrees. That's fine, right? Or if you prefer, you could use 5 pi over 3. That works. Or negative pi over 3. So technically, any of these 4 positive, negative degree radians are acceptable. Okay, so now we just have to choose one. Let's say I'm going to do, let's say, 5 pi over 3. Alright, so we're going to do 5 pi over 3. Alright, so we just converted this part to our trigonometric. So now we can do this part, raise it to the 3rd power. So we'll have 6 to the 3rd power. Alright, cosine 3 times 5 pi over 3, which is really convenient. That the 3 here will cancel with the denominator of 3. So you can see in this case, some people are adverse to wanting to do radians, but in this case, radians actually makes this problem a lot easier. Otherwise, you just get a big number for your degrees. So we have 6 times 6 times 6, which is 2, 36, 16, 216. Right? And like I said before, these 3's will just end up canceling out. Oh, I forgot the 3 there. There we go. So we have 5 pi, right? So that's around the circle twice. That's 4 pi, and then 1 more pi. So that makes this cosine of pi. I sine pi. So we have 216. Cosine of pi is negative 1. Sine of pi is 0. So our answer is just equal to negative 216. And of course, you'll get the same answer if you ended up, doing negative pi over 6 or something with degrees. All right, next, let's look at finding all the cube roots. Right, so this is the same thing as above, but cube root implies it's raised to the 3rd negative 1/3 power. So if you want to, you could rewrite it like this, and just what they're saying is, what is 0 minus 8i to the 1/3 power, right? So we'll do the exact same process as we did here, okay? With a little different twist, as you already know. So the nice thing about when you don't have that real or imaginary part, if you only have one of the 2 parts, it's going to lie on the axis somewhere, right? Which makes finding the radius and theta way easier. All right, so negative 8i is down here, right? Because it's 0, right? You don't go left or right, you just go down 8i. So the distance between here, the origin, and 8i is simply 8. So the radius is obviously 8. All right? So we have that much. And we have the cosine and the sine. Well, what angle is this, right? Well, what angle all the way around? Well, that's just 270. Or if you like 3 pi over 2, you can do that as well. Let's do degrees this time. All right, so always you should be happy when you see something with just one part, doesn't have the real or doesn't have the imaginary. It makes this process a lot faster compared to having to calculate like we did up here. We had to calculate the radius and the theta using the Pythagorean theorem and the arctangent. Here, not needed, right? All right, so here we go. Now this is raised to the 1/3 power, right? So we'll have 8 to the 1/3 cosine 1/3 times 270 plus I sine 1/3 times 270. So the cube root of 8, right, for real numbers is simply going to be 2. That's 2 times 2 times 2 is 8. And we got cosine of 90 plus I sine of 90. Okay, so cosine of 90, 0. Sine of 90 is 1i. So our first solution will be 2i. Okay, which means, if you want to check it, that means 2i raised to the 3rd power equals negative 8i. So you can always do a check, say 2i times 2i is negative 4. Negative 4 times 2i does give us the negative 8i. All right, now we have 2 more solutions and 3 total, right? So we have this little thing where we have to rotate to get the next one, and we have to rotate equally all the way around and back where we started. So what we do is we take our angle of rotation is going to be the full circle divided by how many roots we have. In this case it's 120. So starting here at my first root, my next root is going to be 120 degrees more than that. Okay, so we'll call this one my first root. My second root will just be the same thing, but 120 more than that. And then we'll repeat the same process for the last root. Okay, so we have 2 times cosine of 210 plus I sine of 210. All right, and just know your unit circle, and we have negative root 3 over 2 minus 1/2 I. And this will equal, multiply them together, these 2's cancel out, so we'll have negative root 3 minus 2i. And that will be our second root. Oh, not negative 2i. Negative I. There we go. 2, half of 2 is 1. There we go. And then one more time. So we'll do 2. And we're going to do cosine this time of 210 plus 120. All right, so we do another 120 degree rotation. So we have cosine of 330 All right, now unit circle time. Cosine of 330 is, no surprise, just positive root 2 over 2. Minus 1i. So we have positive root 3 minus I as our next solution. Okay. Now our directions do say to graph on a complex plane. Okay, so we can go over here, and we're just estimating. Okay, so let's say this is 2i right here. That's our first solution. Right, and then we have negative root 3 negative root 3, and negative 1 is down here. That's the next one. And then our third one was just positive root 3 minus I, so that puts it right here. Okay. So that's just a rough sketch of those solutions. And I made this on decimals as well, just to show, if you do this perfectly, what does it look like? Okay, so this would be our first solution, second solution, our third solution. Okay. And remember, this has a radius of 2, so if I make a circle with a radius of 2, all the solutions will fall on that circle, and they all have a 120-degree angle between them. All right, so that's how it looks if it's perfectly graphed. But we're just going to estimate it on ours. Okay? All right, let's move forward and do the next. So we want to find the fifth roots of 32. All right, so fifth roots, of course, means raised to the 1/5 power, or if you want to think about the fifth root, we can do it like that. So again, we just have a real part, no imaginary. That makes this a lot easier. The radius and the theta are going to be obvious. So 32, remember this is 32 plus 0i, so that just puts it right here. Right? That's 32 plus 0i, of course with a radius now of 32. And a theta of 0, right? We're on the angle 0. So it makes it really easy to start this problem. And I'll just write that down, 32, and we have theta 0. There we go. So we have 32. This out of there. No. Go away. Brother. There we go. And we have cosine of 0, 0, plus I sine 0. And this is going to be raised to the 1/5. So nice thing when we're dealing with a real number only here, and no imaginary part. We have an angle 0. So I'm going to write this out. It's going to be 32 to the 1/5. Then it's going to be cosine of 1/5 times 0, which is just going to be 0. So it keeps this problem really simple. Very convenient. So 32 to the 1/5 power, or what times itself 5 times equals 32. That would be 2. 2 to the 5th power does equal 32. So, really nice problem that executes really fast. So we have 2 times cosine of 0, which is 1, sine of 0, which is just 0. So our first solution, no surprise, right, is just equal to 2. Right? And we already expected that. We actually did the problem right here, right? But now we have 4 more roots, right? Which are going to be in the complex realm. So we have 0 degrees, which we could look at it as, so you got 360 degrees here. And we're going to have, what, 5 roots total, right? That gives us 72, a rotation of 72 degrees. Now this is a little different, right? Because before we always had 30 or 45 or 90, right? We don't know cosines and sines of multiples of 72. Now that's why in the directions it says leave in trigonometric form, meaning we don't need to do the last step we did on all these ones where we change it to this format. When it says leave in trigonometric form, that means just leave it in this format. So we can have 72s and 144s and all the different angles and not have to worry about the last part of the problem. So in a sense, if you see this direction, it means less work. You don't have to do the last part. So our first solution was this. Right? Second solution is going to be 0 plus 72, so it's just going to be 2 cosine 72 plus I sine 72. And again, nothing else to do, right? Leaving it in this form. So see how fast this is? And next, just add another 72. So we got cosine is 144 now. plus I sine 144. 144. And then our fourth solution will be another 72. So that's going to put us at 216. Yes? Okay. I sine 216. And our last solution, fifth root, another 72, which is going to be 288. So cosine 288. And if we kept on going, another 72 would put us back to 360, our first root. Right? So it goes all the way around. So, and that's it for this problem, right? So we have all 5 roots, 2 being the only real one, and the other 4 that are still in trigonometric form because we don't know the sine cosines of these angles. All right, next we got the last problem. Okay, so now this is basically asking you to do the problem, the exact same problem, 2 different ways. All right, first do it by making each complex number in trig form. So make the top in trig form and the bottom in trig form. If you need a reference, go back to the beginning right here. Right? You're basically doing this process for the top and bottom. And then you're going to divide it using this process because you're going to have 2 trig form coordinates, and then you're going to do this process to get the answer. All right? Now part 2 says just do it as complex numbers. That means do this. We're just dividing them, do the conjugate, and get the answer that way. And you should get the same answer by doing it 2 different ways. Right? That's the main purpose here, is do the same problem 2 different ways, make sure you get the same answer for both. Okay. Alright, so let's see here. What do we want to do first? Let's take this and do the r squared, right? So that's 6 squared plus negative 6. We're just finding the radius. So we'll have square root of 36 plus 36, which is 72. And when we take the square root of 72, we end up with 6 radical 2. Okay. Now, if you know the shortcut of just multiplying, well, the rise and the run are the same, the 45, 45, 90, and you just multiply the leg by root 2, that will get you there as well. The angle, same thing. What quadrant are we in? Okay, so think about the theta. We're in positive x, negative y, so that puts us in the 4th quadrant. Okay, so arctangent. If you need to do this, that's fine. If you kind of know what the answer is already, you might not need to write this out, because as the more you do, you kind of see the patterns. So, yeah, negative 1. What has a slope of negative 1 in the 4th quadrant? All right? And that'll give us an angle of either 315, or you could say like negative 45 degrees or negative pi over 4. You could do it either way if you want to do degrees, radians, or you want to do positive or negative angles. Okay? So that's the first part. So from this, let's see how to organize all this. I got enough room. Okay. So from this, I can write my first part, which will be radius is 6 rad 2. Cosine, actually, I'm going to give myself a little more room. Cosine negative 45 plus I sine negative 45. Okay, there we go. Now do the same thing on the bottom, right? So let's do this here. Same process. I need my radius squared. And you can see the patterns again. This was 6 and 6, right? Came out to 6 rad 2. So you can probably expect that this comes out to 2 rad 2 by Pythagorean theorem. And our angle, once again, we can see negative and negative, so our angle is in the third quadrant, right? Arctangent of -2 over -2, which is just arctangent of +1, right? So we're dealing with a 45-degree angle in quadrant 3, right? 45-degree angle in quadrant 3 is going to be 225. Right? Degrees. So from that, we can now do this. We got radius is 2√2 cosine 225 plus I sine 225. And we're just doing division, right, to complete this problem. So we're going to divide, right, 6√2, divide the radii, right, and the cosine is just going to be the difference of our angles, using the same rules we did before. That's 225. There we go. Okay. And we can simplify all of this now. So we have √2's canceling out. We have 6 divided by 2, which is 3. And we have cosine -45 minus -225, which is going to be negative, what is that, 270, yeah, 270, plus I sine 270, negative. Now this is the same as 90, right? So this is just going to be cosine of 90 is 0, and sine is 1. So 3 times here, we get our answer of 3i. Alright, so we did it using the trig form. Alright, this is part 1, part I. Alright, that's what we just did here. Now, let's do the second part, double I. Let's use it just using the complex numbers as written. So in other words, let's use the conjugate. Alright, so conjugate time. Let's do some parentheses. And we're going to multiply by -2 plus 2i. Alright, so just got to be careful on our details and we should be fine, and our hope is it comes out to the same as our first part. Okay, so we got 6 times -2. We get -12. 6 times 2i, we'll get 12i. -6i times -2 is positive 12i. That's nice. And then we get -6i times positive 2i, so it's -12i squared. Okay. All over, same thing on the bottom. So remember, these are conjugates, so there's not going to be any middle terms, so I really just need to do -2 times -2. Positive 4, and then -2i times positive 2i, which is -4i squared. Simplify both. We have I squared here, so that's going to become a positive 12. I squared here becomes a positive 4. So now we have, let's see here, we have negative 12, positive 12. So those cancel out. So I'm just left with 24i, right? And on the bottom I have 4 plus 4, which is just 8. Of course, 24 divided by 8 is 3i. So those match, right? Very important that those match. All right, so that is the review. Make sure you can do all these problems on your own. Redo the problems many times so you don't have any pauses. If you need to, brush up on your unit circle, right? You cannot have that during the quiz, so you need to know it. Otherwise, a lot of these problems become a lot more difficult without knowing all those coordinates. All right, good luck.